For decades, software waited patiently, a silent servant, executing our precise commands. It was a tool, an extension of human will. But beneath the surface of recent breakthroughs, something fundamentally different has begun to emerge. A new generation of artificial intelligence capable of more than just responding to prompts, but of perceiving, reasoning, planning, and executing complex tasks entirely on its own. If the Industrial Revolution gave us machines that replaced physical labor, these new AI agents are poised to become the world's first true digital workers. Not just software you use, but software that works for you independently, transforming the very nature of knowledge work itself. But how did we get here? From simple logic puzzles to systems that can browse the web, write code, and make decisions. And what does it mean when the tools we created start acting like colleagues, or even employees, raising profound questions about the future of every profession? The answer lies in a story stretching back over half a century. A story of forgotten ideas, impossible dreams, and a sudden, unexpected leap forward. Our journey into intelligent machines didn't begin with silicon, but with signals. In the 1850s, telegraph networks stitched the world together, allowing information to travel faster than any human messenger ever could. It was a revolution in communication, mirroring the Industrial Revolution's impact on physical labor, where factories filled with machines dramatically amplified human strength. These were machines of brute force or rapid communication, but they lacked something essential: intelligence. The theoretical groundwork for that intelligence was laid by Alan Turing in 1936 with his universal Turing machine, a blueprint for any computer imaginable. 14 years later, in his seminal 1950 paper, Computing Machinery and Intelligence, Turing dared to ask, can machines think? He even proposed the Turing test, a simple yet profound benchmark for machine intelligence. Just 6 years later, in 1956, John McCarthy gathered brilliant minds at Dartmouth, officially coining the term artificial intelligence, and a new field was born. Early AI in the 1960s was an intellectual playground focused on symbolic reasoning. Programs could solve logic puzzles, demonstrating a rudimentary form of thinking, but they were brittle, unable to learn or adapt beyond their programmed rules. Systems like ELIZA in 1966 offered a glimpse of human-like conversation, deceiving users into thinking they were speaking to a person, despite having no genuine understanding. Then came expert systems in the 1970s, rule-based programs that codified human expertise, finding niche applications, but still far from true autonomy. Yet even then, the seeds of future agents were being sown. In 1980, the ContractNet protocol introduced the idea of distributed task allocation among software entities, hinting at systems where digital components could collaborate. Throughout the 1980s, research into multi-agent systems gained momentum, exploring architectures like belief, desire, intention, BDI, where software entities possessed beliefs about their world, desires for goals, and the intention to act. By 1995, the textbook Artificial Intelligence: A Modern Approach formalized the concept of intelligent agents as the standard way to think about AI, defining them as systems that perceive, act, and reason within an environment. The idea was decades old, waiting for the technology to catch up. Then came Deep Blue in 1997, defeating Garry Kasparov, a triumph of brute force calculation and specialized algorithms. But it wasn't intelligence in the broader sense. The real shift began with deep learning. In 2012, AlexNet revolutionized the field, making deep neural networks practical for the first time. This was followed by AlphaGo's stunning victory over Lee Sedol in 2016, showcasing unprecedented capabilities in planning and reinforcement learning. The building blocks were being assembled piece by piece, leading to an explosion. Then, in 2022, everything changed. ChatGPT arrived, not as a specialized system, but as a general-purpose conversational engine. Large language models, or LLMs, were suddenly mainstream. We could talk to AI, and it could talk back, generating coherent text on virtually any topic. It felt like magic. But for all its groundbreaking ability to communicate, ChatGPT, like other chatbots, remained fundamentally reactive. It waited for a prompt, then responded. It didn't decide what to do next. It didn't plan. It didn't initiate action in the real world. This was the fundamental tension. Immense linguistic capability, yet limited agency. Researchers quickly recognized this limitation. What if an LLM could not only generate text, but also reason about it? Goals: plan a sequence of steps and use external tools to execute those plans. This idea, already deeply rooted in AI literature, became newly practical. Seminal research papers like React, published in 2022-2023, demonstrated how LLMs could combine reasoning with external action, laying the groundwork for true AI agents. Instead of simply answering a question, an LLM could now decide, for instance, that to answer a question about current events, it first needed to browse the internet, then synthesize information, then present its findings. It wasn't just generating text, it was acting. The floodgates opened. In 2023, projects like AutoGPT, Baby AGI, and MetaGPT captured the public imagination. These systems promised fully autonomous task execution. You could give them a high-level goal, and they would break it down, research, plan, and try to achieve it. The excitement was palpable. The internet buzzed with videos of AIs trying to build businesses, write code, or even manage social media. But these early ambitious systems quickly hit a wall. They were often unreliable, prone to hallucinations, or getting stuck in repetitive loops. Their chains of thought, though impressive when they worked, frequently failed. Tool use was clunky, and long-term memory remained a challenge. The dream of fully autonomous digital workers felt tantalizingly close, yet still out of reach for production use. The stakes were clear. Either we build more robust, reliable agents, or the promise remains just that, a promise. This period of widespread experimentation and public fascination revealed a crucial insight. The problem wasn't just making LLMs smarter, but engineering the surrounding architecture to give them genuine agency. The core components of an intelligent agent, memory, planning, tool use, feedback loops, and environment interaction, had been theorized for decades. Now, with powerful LLMs as the brain, these older concepts could finally be brought to life. The twist was that the most revolutionary aspect of modern AI wasn't just the large language models themselves, but how they enabled the ancient dream of the intelligent agent to become a practical reality. We weren't just building better chatbots. We were building the first digital employees. The industry understood this shift. By 2024 and into 2025, major AI companies began pivoting their entire product strategies. The conversation shifted from chatbots and assistants to agents. OpenAI, Microsoft, Google DeepMind, Anthropic all started shipping agent frameworks, SDKs, and enterprise tooling designed for delegated tasks. These new systems could do more than just talk. They could control a browser, interact with a computer's operating system, write and execute code, connect to external APIs, and manage multi-step projects with minimal human oversight. Companies were not just selling models. They were selling the capability for digital delegation. This was the beginning of the next industrial revolution, the race to build AI workforces. Imagine a digital office where one AI agent acts as a project planner, delegating tasks to other specialized agents. A researcher agent scouring databases, a programmer agent writing and testing code, a marketing agent drafting campaigns, and a reviewer agent ensuring quality. This is no longer science fiction. Multi-agent systems are already being developed to simulate entire digital companies. NVIDIA's Jensen Huang, Microsoft's Satya Nadella, OpenAI's Sam Altman, Google DeepMind's Dimas Hassabis. They are all explicitly framing their future not just around smarter AI, but around AI that can act autonomously on our behalf. This is the point of no return. We are moving from software you operate to software that operates on your behalf. The potential is staggering, automating vast swaths of customer support, accelerating software development cycles, performing complex data analysis, even personalizing education on an unimaginable scale. But this power comes with its own set of challenges. Hallucinations remain a persistent issue. Unreliable long task chains can still break, tool failures happen, and the compute costs can be astronomical. And then there are the ethical and security concerns. Prompt injection attacks, the potential for misuse, memory limitations, and the fundamental question of how we ensure these autonomous systems align with human values and goals. The genie is out of the bottle, and it's not just talking, it's working. The revolution isn't a single event, but an ongoing process. While fully autonomous, perfectly reliable AI agents are still an aspiration, the trajectory is clear. Companies are investing billions into overcoming current limitations, pushing the boundaries of memory, reasoning, and tool use. The focus has shifted from simply making models intelligent to making them reliable employees. Progress is being made on reducing hallucinations and making long task chains more robust through sophisticated feedback loops and self-correction mechanisms. The high compute costs are slowly coming down as hardware improves and models become more efficient. The industry is moving beyond the initial hype cycle of AutoGPT, refining these systems for enterprise-grade deployment. The challenges are formidable, but the rewards of a truly autonomous digital workforce are driving relentless innovation. We're not at the destination yet, but the journey has begun, and the first digital employees are already punching in. The rise of AI agents isn't just another technological upgrade. It's a fundamental redefinition of our relationship with machines. For centuries, our tools have extended our physical and mental capabilities, but they always required our direct, moment-to-moment supervision. Now, we are building systems that can perceive, plan, act, and adapt with genuine autonomy. This shift is arguably more profound than the internet, which connected us to information and each other. AI agents don't just give us access to information, they act on it. They don't just connect us, they perform work for us. This changes everything, from how businesses operate to the very nature of human employment. Every profession will be impacted, not necessarily by replacement, but by transformation. The lesson is clear. The future belongs to those who learn to collaborate with these new digital colleagues, not just command them. We are no longer just users of software. We are becoming managers of AI, workforces ushering in an era where our most valuable skill might be our ability to delegate to and oversee intelligent agents. What kind of world do you imagine when AI agents are commonplace? How do you think your own work might change? Share your thoughts in the comments below, and if this exploration into the future of work resonated with you, consider subscribing for more deep dives into the forces reshaping our world.